Hi guys. I think I have more people to admit. Morning.
Good morning.
People are still joining.
Morning.
That sounded sleepy.
Yeah.
Okay. So today, just want to go over format for the final, which is on Monday. Want to answer questions on previous exams. If you have the exams, you can now see. I'm still trying to admit, the correct answers for the last two. The exam 2, the multiple choice that's on Pearson, that will be available to you up until midnight the night before the final. So you can look at that. So when you are studying, what I would suggest is go over your old exams, make sure that you understand the answers, practice the homework. For taking the exam, you can have one side of a regular 8.5 by 11 sheet of paper, your periodic table, and of course your calculator. The exam will have 50 multiple choice questions. I think I'm going to bump this up to 4 hours, just because it could wind up being a bit long. And there are some written response questions that will also, it will all be in Canvas, but same thing where you will be uploading a file after the exam time. It's not letting people in. Okay, I think they're coming. Yeah, so there are some questions that every 152 lecture in the department has on the exam. Those will probably be part of, but not all of the 8 written response. But everything will be in Canvas. And what I want to say, just so that you know, there was, I guess, some people, you weren't so sure about what to include on your papers for the last exam. Any question that's worth more than 1 to 2 points, write it down on your paper. You're probably writing it down anyway. Just submit that, because I can give partial credit. Like I can remember specifically, there were a couple 8-point questions. I don't know why it's not letting people in. Okay, now it looks better. Oh, yes, there were a couple 8-point questions, and if the answer was incorrect, I would most likely, if I had seen the work, if you had written down the right equation, that would have been worth at least 3 points. And if you had substituted in the numbers correctly, then that's another point or 2. I saw there was one dilution question where everybody put the wrong volume in the wrong, not everybody, but a bunch of people put the wrong volume in the wrong place. Like they thought V2 was V1. And if I can see that, then and the number works out, then that's worth a lot of the points. But if I don't have anything to look at, then I can't give partial credit. So write stuff down. I would say in general, the more you submit on paper, the better off you'll be. You guys have any questions?
Professor, you said that the answers for exams 2 and 3 are on Canvas?
So let's go through them one at a time. Exam 1, you have everything, right?
Yes.
That back. Okay, exam 2 was the first one we had after we went online. For that one, the multiple choice was on Pearson. And that one you can see just like you can see any homework on Pearson. And that one I'm planning to keep open until the night before the final. For exam 3 and exam 4, those were all on Canvas, and those are open until noon today. I have I
And
have colleagues that don't share exams, and don't hand them back. So it's a little bit sticky for me to open it, but I feel really strongly that you need to be able to look at the questions that we've already done and try to understand, and you learn from your mistakes. So, but I can't, and also because things are so easily shared on internet, I can't leave it open for an extended period of time.
question,
Uh-huh.
uh, those exams 3 and 4 on Canvas, whereabouts in Canvas do you go to look at those? In
They
grade?
should, they should be, yeah, you can access it from there. You should also be able to see it under modules, I would think.
Okay, modules.
But I think if you go to your grade book and you click on it, it should give you the opportunity to go look at it too.
And these are the correct responses to the exams 3 and 4?
Yes.
Okay.
Yeah. What did you guys find the most challenging in the last exam?
I said I had a flood of too many formulas in my head. I think I knew what I wanted to do, but and I got rushed, so I started making some careless mistakes. After the exam was over and I sat down after the exam, things started coming to me. And I'm thinking, oh man, I should have did it that way, or I should have did it that way. But in the heat of battle, I couldn't think straight.
Well, it looked like you did pretty well.
Yes, I did. I did better than I thought I was going to do.
Yeah. Do you guys have questions now on old stuff?
Not right now, Professor. I feel like I'm probably just going to review the material over these couple of days.
Yeah.
I do feel like this last exam was a little bit more challenging for me. And what would have helped me would have been to do the lab before taking the exam, but
Yeah.
I completed the lab after, and that was very eye opening because after doing the exam, then I understood I was able to understand better like a couple of the final questions on that last exam.
Yeah, I understand that. And I think with the original schedule of the lab, we would have been doing checkout when you were doing, like it would have pushed things forward 1 week. Yeah, but you have it now. And the good thing about the final is that there won't be anything new. It's all material you've already been tested on. Yeah, and yes, you do need to take, I just see a question from Molly. The final needs to be taken during the class time. They give us 5 business days to get grades in, which is not very much time in the spring. We get more time in the fall semester. I don't know why, but I guess it's because of the summer courses. They need to have everything in before that. You have to check with your schedule, Molly, for the lab exam. If you run into a scheduling conflict, our class time should take priority, but just let me know if you think you're going to have an overlap issue. I know we have so much time between this last class period and the exam, and I'm sure you guys all have other stuff that you've been studying for, so you may not be quite yet up to speed for the review. But the good thing is the stuff that we learned at the beginning of the semester usually feels pretty simple by now. I always tell people what they really need to do is, you look at, I see a question over 37. I think that's a good one to do. I'll see if I can pull that up. Oh yeah, you just need to you need to left shift your learning curve, because people, we learn stuff, we take an exam on it, and then we move on. And then at the end of the semester, you look back at the stuff that you struggled with at the beginning of the semester, and you go, oh, that was so easy, I can do that now. Well, if you can do it now, you could have done it then. You just needed to shift everything by a month or so.
So the exam will be on 9:30 Monday during, it'll be open at 9:30 on Monday,
Yeah,
final?
yes,
Okay.
yeah. It's really being slow about letting people in today. Okay, so I got a question for question 37 on the exam. Let me see if I can pull it up. Modules. Oh, no, I gotta go to. Of course, my computer is slow. I think for some people there were a couple questions where there was a stoichiometric coefficient that people omitted. Okay, I'm getting there.
Well, you're getting there, Professor.
Uh-huh.
As far as you know, is the plan to have online classes this fall?
Yes. So I know you don't want to hear that, but the plan, it's confirmed that in the community college system that the lectures will be completely online, and there are some labs that they may try to do partially live on campus. They're looking at ways of doing it. They're not yet decided. And it's going to be more of the advanced labs. So if you are looking at taking 200 or 201, there's some chance that those will be in person. Okay, I'm scrolling. Let me pull this up. Okay, you should see some questions now, yeah? Okay, this one here. Oh yeah, I know what happened with this one. Okay, so the question is, consider the reaction. You have 2 methane gas reacting and making acetylene, C2H2 gas, and 3 hydrogen molecules. And the measured concentrations of CH4 methane is 0.071. Acetylene is 0.065. And the question asks us what hydrogen is, and the equilibrium constant is 0.154. Okay, now I'm going to switch to my camera. Okay, so there's our problem. Poor Leah, I keep admitting her and she keeps not getting in. I don't know what's going on. Okay. Okay, so here's our equilibrium reaction. The equilibrium expression would be that K is equal to C2H2, the concentration, times the concentration of hydrogen cubed, divided by the concentration of CH4 squared. And we have been given that K is 0.154, C2H2 is 0.065. We'll call the concentration of hydrogen X, and that's cubed. That's what we're solving for. And the concentration of methane is 0.71 squared. So See if you can see this. So when we solve for this, we'll multiply this times that to get rid of it. We multiply both sides by 0.071 squared. So it's 0.154 times 0.071 squared divided by 0.065, and that equals x cubed. And that comes to 0.154 times 0.071 squared divided by 0.065. I get x cubed 0.00119. And if you got there, you got most of the points. What you have to realize though is that's giving you the value of the cube of the hydrogen concentration. You need to take the cube root. And the way you do that is with an exponent of 1/3, because when you raise something to a power, you multiply the coefficient. So 1/3 times 3 gives you x. And then you take this number and you raise it. Go back to 1 divided by 3. Oops, let's go syntax error. Delete. And that gives you 0.229 molar for the hydrogen concentration. Questions on that one? So if you got to the Q part, that was most of it. And that meant you understood this is one from the end of the chapter. I've been taking most of the questions from the end of the chapter questions. So they're all there, and usually they're ones that are paired. There's an odd one with the answer and an even one that doesn't have the answer in your book. Okay, let me see. I think there was another question. Got question 37. Does anyone have other questions? People approached some of the other questions in a way differently than I would have. And sometimes it works, but you can get into trouble. So let me re-share this and let's look at some of the other questions. Oh, okay, question 38. You guys see this, right? The phosphorus trichloride plus chlorine makes phosphorus pentachloride. So remember to review your naming and formula writing based on names. Okay, so indicate the effect of the change. Actually, this isn't the one that people had trouble with. There was one other one.
Well, that was no trip to Hollywood either. 41.
41.
That was no trip to Hollywood.
Most people did pretty well on it. Why?
Why? Too many choices.
Too many choices? I narrowed them down for you.
I know you did. I think I suffered through that one.
Yeah, actually people did pretty well on that. Computer's slow today. And poor Leah is not getting in. Okay, so if you look at this, you guys can see the acetone, right?
Right.
Acetone cannot hydrogen bond with itself because there are no hydrogens on it that are attached to O or N or F. Okay, so it's no on the hydrogen bond. Dipole-dipole interactions it can do because we have this polar bond, the C double bond O has a dipole, so it can participate in dipole-dipole interactions. Everything can do dispersion forces.
Yes.
So it should be yes across the board here. And then the strongest IMF would be the dipole-dipole. Okay, now propane has only C and H. So there are no, if it's a hydrocarbon and there's no O, no N, no S, no halogen, if it's only carbon and hydrogen, it can only be, it's definitely nonpolar. And the only interaction it can have is dispersion forces, and that will be the strongest one. Now, the ethanol, stupid windows in the way. Ethanol, we have, sorry, we have we have hydrocarbon part, but there's also this hydroxyl group. So here we have a hydrogen that is covalently bound to an oxygen. That one is eligible to be donated as a hydrogen bond donor, and then the oxygen can accept the hydrogen bonds. So ethanol can hydrogen bond with itself. Anything that can hydrogen bond can also have dipole-dipole interactions, and everything has dispersion forces. And whenever there's a hydrogen bond, we'll say that that is the strongest IMF. And anything that has hydrogen bonds will have a higher boiling point than things that cannot hydrogen bond. And the lowest boiling point will be the one that is only a hydrocarbon. Guys did good on mass percent. Guys did good on this one, I think. I think the format of this question confused you. Generally, people did well, but sometimes they put more time in here than they needed to. I didn't need the equilibrium constant here. I just wanted a number so that you could commit to an answer before you submitted the quiz. So people generally understood that. Remember, I think in the heat of the moment, people forgot we do not include the carbon sulfite in the equilibrium constant because it's a solid, and we don't include the water because it's a liquid. Most people did okay on this. For this, identify each substance as an acid or a base, conjugate acid or conjugate base. So this is nitrite, and it's a reactant. It's pair on the product side that looks almost the same, but just differs by a hydrogen is nitric acid, or nitrous acid, sorry. So this is going to be the base. And if this is the base, that means water has to be the acid. And we said that that was the conjugate acid. And that means that the hydroxide has to be the conjugate base. I'm looking for,
Professor,
uh-huh.
can you go back to 35?
Yeah.
That, I think I may have gotten this one right by just plain sheer luck.
Okay.
That NO2,
This one?
that would not be a proton donor, correct?
Correct. It has no protons to donate.
I got it. Okay, so it would be a proton acceptor, correct?
Yes.
So that would make that a base.
Yes.
Okay, and the water would be the acid because it can donate that one hydrogen over to that OH over there, correct? So
It donated the hydrogen to the NO2. But water, remember, water can be an acid or a base. You have to look at
right
text to be able to tell.
Yes.
So,
Okay.
but if you see water on one side and hydroxide on the other side, then this water is going to be an acid.
I got it.
If you see water on this side and you see hydronium, H3O plus instead on the other side, then this is going to be a base.
Okay. So it will always be, if you see H2O on one side and OH on the other, that's going to always be, water is always going to be an acid, and OH is going to always be your conjugate base, correct?
Yes. Yeah.
Okay.
Yeah.
I got to remember that.
There was one question about adding a solid to an equilibrium mixture that people got wrong. I'm trying to find it. No, not that one, not that one. People got that right. Oh, sorry, I can't find it. Let me see. And let me just remind you then on the camera, because I don't remember the exact problem, but how to get an eraser. Hold on a sec. There it is. Okay, if you have an equilibrium where a solid is reacting, or maybe it's a KSP where something is dissolving. Imagine we have magnesium hydroxide and it's weakly soluble. If you look at the solubility rules, you would expect it to be insoluble. The equilibrium constant for this, and because this is a solid, this is aqueous, and this is aqueous, we call it a KSP. That's just the solubility product. And the equilibrium constant would be the concentration of magnesium times the square of the concentration of the hydroxide concentration. Notice that this, the solid, is not in the equilibrium expression. So by Le Chatelier's principle, if I add more of the magnesium hydroxide, it has no impact on my equilibrium concentrations. It doesn't factor in anywhere. So adding the solid has no impact on the equilibrium. And the everyday example that I gave to relate to this is that if you have your tea and you're mixing in sugar and there's already sugar on the bottom of your tea, in that case, we're looking at this solubility product, sucrose solid. Sucrose solid in equilibrium with sucrose in its aqueous form. This is also a KSP, and this is my sugar going into the tea. It's only dependent on the concentration of the sucrose in solution. This is not included. Question 40, okay. And so adding more sugar to your tea, if there's already sugar solid sitting on the bottom of your glass, does not get any more of it to go into solution. It's not going to make your liquid tea any sweeter, although it'll be sweet when you get to the bottom of the glass and the sugar comes down too. So there was one question where it was a question about Le Chatelier's principle, and it asked, if I add more solid, what will happen to the equilibrium? And there's no effect. Okay, question 40. Let me look at question 40. I'm just sending Leah a quick email. Okay.
I think you're showing us your email, Professor.
Yeah, sorry. I mean to do that.
I'm sure there's nothing in there we don't need to see.
There's probably tons you don't need to see. Leah keeps trying to get into the Zoom session and she's not getting in. I don't know what's going on. I just wanted to know I could see that she's trying. Okay, here's question 40. Oh yeah. Okay. So okay, so I'm gonna reconstruct the chart and then I'll do it on my board. Concentration of OH minus, concentration of H3O plus, pH of acid. 1.2. Okay. Okay, here we are. So pH of 1.2. The relevant equations are pH is equal to minus the log of the H3O plus concentration. 10 to the minus pH gives you the concentration of H3O plus. Concentration of OH minus times the concentration of H3O plus is equal to 10 to the minus 14. So for this first one, I'll probably do the hydronium concentration first. So that would be 10 to the minus 1.2, and you have to put it into proper scientific notation. And so on my calculator, I hit 10 to the negative 1.2, and I hit enter, and I get 0.063 molar. And because the units, the decimal's not so bad, this is an okay answer without doing the scientific notation. I know that this is an acid because the pH is below 7, so that's acid. Now to get the hydroxide concentration, I'm going to take 10 to the minus 14 and divide by the H3O plus concentration to get the hydroxide concentration. And that is 10 to the minus 14 divided by 0.063. So 10 negative 14 divided by 0.063. Oops, I gotta. And I get 1.59 times 10 to the minus 13 molar.
Can you slide your camera up a little bit, Professor?
Yeah.
Or your whiteboard? Yeah.
Can you see it now?
Yes, thank you.
Okay, so that is 1.59 times 10 to the minus 13. Okay, for the next row, I see that this exponent is -3, which is pretty small for the pH scale. So I'm expecting that this one is going to be a base. And but I'm going to go ahead and calculate things out. So Kw 10 to the minus 14 is equal to the hydroxide concentration, 5.3 times 10 to the minus 3 times the hydronium concentration. So I'm going to divide both sides by this number. 10 to the minus 14 divided by 5.3 -3, and I get the concentration of hydronium is equal to 1.89 times 10 to the minus 12 molar. Okay, so that goes here. And I take the log of that, the negative log of that will give me the pH. And that comes out to 11.7. So indeed that is basic because 11.7 is higher than 7. This one you should be able to do without using your calculator when the concentration of hydroxide is 1 times 10 to the minus 7, the concentration of hydronium is also 10 to the minus 7 because this times this is 10 to the minus 14. That means the pH is neutral, is 7, and it's neutral. You could also use the equations, it just takes longer, but you'll get the same answers. Don't forget things like electron configurations, naming, please do naming. Trying to think what else. Your previous exam should really help. I think you guys are pretty solid on Lewis structures and geometry. The things that you might need to review more. I mean, the good thing about this class is it's vertical, right? That you are using the stuff from the beginning of the semester now, so the reviewing should be fairly straightforward. There's just a couple excursions that you might want to look at in more detail. Probably like classifying chemical reactions is something that you might want to revisit, electron configurations, but look at your old exams. New questions? Oops, that's not what I want to do. Can you believe we're here? We made it to this far.
Yes.
I could tell you, I mean, you guys are, I'm sure, not feeling it, but this is way more relaxing for me than it was the first time we did a Zoom class.
Oh, that's good.
I'm sure you guys don't want to hear that now because you're all stressed out. But it's still not perfect. I'd much rather be doing stuff, walking around the classroom and looking at your papers and watching you work. But at least we got to finish it, and I think you guys have stepped up, and I know it takes, you sort of have to take on more responsibility, I think, when you're learning this way.
Yeah.
But there's some benefits to that. I wonder if my kids are going to be more prepared to learn independently when they go to college after having done this year in school.
Oh,
You know
wow.
what
How
I
are
know
you?
I missed most, Professor, is that tutoring lab they had over there
Mm.
where you had a question. I missed that.
You know, that's worth pointing out. I'm gonna, and that's good feedback because I'm sure that we'll be able to come up with something. It would still be virtual, but I'm sure we'll be able to provide some kind of resource in the fall where people can come and get questions answered.
Professor,
Uh-huh.
I have a question. For campus like resources, for example, like the financial aid department and admissions, do you have any idea when they'll start their remote operations?
They're not doing anything remote?
No, I've actually been trying to contact financial aid for like a couple of weeks now, and I've sent multiple emails, but I haven't gotten a response.
I would have thought that they would be open already. At least virtually.
Yeah, same
Let
here.
me- So it's financial aid and student services?
Yes.
Okay. I'm gonna write that down. Send me an email separately
Okay.
and I'll see what I can find out.
Perfect. Thank you, Professor.
Yeah, you guys need answers about stuff like that. I think it's gonna be fiscally it'll be an interesting fall because there's some anticipation that some students will defer going to a four-year college in the fall and then instead stay local at their community college.
Oh,
And at
wow.
the same time, they're talking about potentially cutting our budget.
What? Oh, man.
We're
Mm.
expecting to offer a full load of courses, but yeah, so it's going to be interesting to see how it all gets handled. I mean, there are some things, the virtual labs are less expensive than the live labs to run. So maybe resources will get shifted. But yeah, it's going to be interesting.
Yes.
I sort of think that the San Diego Unified is going to have some version of open classes in the fall.
Oh, same for Poway Unified. Poway Unified actually sent a survey recently for parents asking if, you know, if they feel comfortable enough to send their kids to school with the required restrictions
Uh-huh.
implemented. And so it's been a hit and miss, but I have a feeling that Poway Unified might try to go partially online as well.
Yeah. I mean, I think a hybrid is probably the best. I think they should try and then just be ready to shift if we have to.
Right.
I think at the high school level, it makes sense to probably structure it more like a college environment where they come in fewer times a week
Mhm.
to minimize contact. But it sounds like the key to avoiding infection, though, is sitting for long periods of time in an indoor space with a group of people, which is sort of the definition of a classroom. But I don't know. I'm teaching biochemistry, and we made our project studies on the COVID virus, and it's been really interesting to read all the stuff coming out as it comes out.
Oh,
And
wow.
some of the European schools have reconvened, and it sounds like it's working okay so far, but the lag is so long, you know.
Yeah, and it's probably going to take years.
Well, or a vaccine.
Yes, that's
Yeah,
hopefully a vaccine sooner.
yeah. I heard January potentially.
Oh,
As
wow.
like,
Yeah, it's still a couple months from now.
oh, that's. I think that's ambitious.
Yes.
January.
Yes. Yes.
Sure.
Yeah.
Wow.
I think the vaccine is only going to protect those people who don't have it. I mean, if you have it already, I don't think the vaccine is going to help you.
That's true. Yeah.
Yeah, that's true. But and we're still, figuring it out, but hopefully there's immunity that goes along with having had it. Because I've been watching the antibody tests. I'm sort of suspicious of them
Oh,
because I think the common cold is caused by a coronavirus 20% of the time. So you might test positive for the COVID-19 antibodies, but it might be cross-reacting with antibodies that you had against a regular cold and testing positive.
Oh,
It's hard to have something that's really specific, and I think it's going to take time for them to figure out which ones are accurate and sensitive. Okay, more questions, you guys? I think, look back over some of the videos. If you have a question and it seems like a good one for a video, I can make a video and then post it on the YouTube channel on how to solve something. I think my time opens up a little bit now because I'm not totally caught up, but I'm getting there. So let me know. I know this is early for the exam. I think the other classes are actually, a lot of them are doing the exams over 2 days. And so they're already started on their exams. Yeah. Okay, well, if there's no other questions, I'm gonna end it. It's nice to hear voices.
Thank you, Professor.
Oh,
Nice
Thank
to
you.
hear
Thank
you
you.
as well.
stay healthy, guys, and
You
hang
as
in there.
You too.
It's the final hurdle. All
Bye-bye.
right, bye.
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 Bye, guys.